Red hot penny. Very flammable gas. Ooh, oh, down. Wonder what's going to happen. And you're not going to try this at home, no. Come on, there you went. I'm getting gas, I'm getting gas. Oh. Sweet. Red hot. And I will sit on your head. Sweet. Ooh, that about got my beard. Ooh. In 3, 2, 1. Greetings, I'm Jake Wizard 4, Faraday Studios, where we do Midnight Science Club. DragonCon 2020 invited us to present some science activities, some really neat, interesting science activities, but we couldn't do them inside the arena for safety reasons, and you'll see why. On this particular one, we used acetone, which is very, very flammable, and a red hot penny. Can you imagine taking a red hot penny and mixing it with a very explosive liquid? I wonder what's going to happen. Let's check it out. So this is an uncanny candle situation. Now let's just focus on the candle just a second. If I would ask you what is this yellow stuff right here?
Well, that's a flame.
That is a flame. And of course, being the student you are, you could tell me a flame is made of?
Oxygen, a heat source, and a fuel source.
Okay, that's like a traditional fire triangle, right? Well, that's actually a chemical reaction that's taking place there, right?
Yes.
The fuel goes from a solid to a liquid from the heat and gets sucked, rises up in the string, and then it vaporizes. So it's actually the wax vapors that are burning and making a flame. And one of the products of the flame is what?
Heat. Heat
and some light is given off, right?
Yeah.
And some gases that we don't necessarily see that are going there. So, and that's the traditional flame, right?
Yeah.
But we're going to make an uncanny candle.
Okay.
A non-traditional flame. And we're, like the wax, this is what we're going to use a different fuel. Have you ever heard of acetone?
Isn't that the stuff that is an ingredient in nail polish remover?
Acetone, yeah, fingernail polish remover is a bit, but you'll see it in paint stores. You know, they use it to clean up paint and soften lacquer and stuff like that. It is very flammable, much more flammable than that candle. I'll show you how flammable it is. I'm just going to pour a little bit in here. Do you want to set that, light that up?
Sure.
Ooh,
wow.
Did it go up quick?
It did.
It went up very quick, right? That stuff goes, and just the fumes of it will go up. That's just to establish the point that acetone is very, very flammable. Now get your sparkler ready again. Now just bring that back over here. Still see if there's still some fumes. Ooh, oh, down. Did you see the flame go all the way over here for a second?
Yeah.
That was just the fumes that lit. So acetone's mean stuff. So I have a beaker with some acetone in it. And I have a copper penny hanging on a wire, and I positioned it so that I can hang that copper penny almost touching that liquid, but not quite. And what we're going to do, we're going to take that penny, heat it up red hot, and hang it over that very flammable liquid. Red hot penny, very flammable gas. I wonder what's going to happen. And you're not going to try this at home, no. There we go. Heat that penny till it's red hot. And I'm going to hang it right over the surface of that liquid. What's it doing?
Seems to be getting red and then cooling a little bit.
Good, yeah.
And then suddenly getting red again.
Is it staying hot, do you think?
I think so.
Is it kind of acting like a flame? I mean, a flame kind of flickers, right?
Yeah.
And something's going on between that copper and that acetone, because that should have cooled off a long time ago. What would be keeping it hot?
Maybe the vapor from the acetone?
Vapor? Well, in order for that to keep staying hot, we'd have to keep adding more heat, right?
Yeah.
And that acetone doesn't feel hot. So what could be the source of heat that's keeping that coin red hot? Well, what did we call this up here with a candle? That's a chemical...
A chemical reaction.
Chemical reaction, and it's giving off heat is one of them. A chemical reaction is taking place on the surface of that coin. It's called a catalytic reaction. And the acetone fumes touch that red hot penny, and it breaks down and it reacts just similar to this reaction here. Not exactly. It breaks down, and part of that reaction gives off heat, which keeps the coin hot. And that'll keep on reacting like that, I imagine, for half an hour or so, or at least until we run out of acetone, because acetone's evaporating. But a chemical reaction is taking place right on the surface of that coin. That's kind of eerie, isn't it?
Yeah.
Are you impressed?
Very.
And it didn't have to be a big explosion, right? You're not actually overwhelmed, you're just whelmed a bit, maybe.
Well, what's next, Jake?
What's next? I could just sit here for a half hour and stare at this, couldn't you?
Yeah.
But you want more.
Yeah.
Well, we have more. Let's bring on more science. But first I want to watch this thing in the dark. That is so cool. Wow, that is a loud bell. Hi, I'm Jake Wizard 4, and if you don't know the secret, here at Faraday Studio, every time somebody says the word wizard, a bell goes off. That's just our tradition. So I will not say the word wizard anymore. I want to thank you for joining us today. I hope you enjoyed what you saw. We do science activities that help you sharpen your science thinking skills. In this particular set, we use items you can find around the house. And if you'd like to see some more, find us on the internet. You can find Midnight Science Club at Instagram and YouTube, Facebook. We're all over the place. We've got thousands and thousands of activities here at the studio. It's a 200-year collection, and we're sharing them with the public. So please join us. Wizard.